Okay guys, so today we are going to do proving inverses using composition of functions. So to prove two different functions are actually inverses of each other, you can use the composition of functions and all that should remain is just x, okay? It should only equal x. So if we've already done this before. So if the two functions are inverses, then when you put the function of g inside the function of f, or vice versa, the function of f inside the function of g, everything should cancel out, leaving you just x, okay? It's like if we had f of its inverse of x, right? The f function and its inverse function, everything would end up canceling except for just x, okay? So it would equal x is our answer, okay? So that's what we're looking to see. If they equal anything other than x, then they're not, I didn't mean to put functions, sorry guys, then they're not inverses, okay? So let's look at our first example below. We have f of x and we have g of x. We want to prove whether they're inverses. So what you need to happen is, well, f is going to be black. So we need f of, and we're going to put g in the middle. Okay, we need to figure out what that's going to equal. And then we also need to do the same, but with f in the middle. Okay, and see what that equals. Okay, so what I mean is I'm going to take my f function, okay, and in place of x right here, okay, where x is, I'm going to take what g of x equals, and I'm going to plug it in for where x was, okay? So I'm going to have f of g of x equals, okay, so we're here, but we put g in the middle where x was. So in place of x, I'm putting square root of x minus 1, okay? And then I'm finishing the rest of the problem. So the plus 1 is the same, the squared's the same, the only thing that's different is where x was, I put in g, square root of x minus 1, okay? So then we want to simplify and see what we're left with, okay? Well, what we know is that, I'm going to make this pink. Okay, here's my g part. So what we know is we know that squaring a square root would cancel each other out, right? So square root and squaring would cancel each other out, which would leave us just x minus 1 plus 1. Minus 1 plus 1, 0, so we're left with just x. So that means that these two functions are inverses of each other. You want to check it the other way as well because it needs to work both ways in order to be inverses. Sometimes it could only work for just one and then not the other, so we want to verify, okay? So then what we're going to do over here is we're going to do the reversed, okay? We're now going to take what my f function is equal to, and we're going to plug it in for this x, okay? Meaning, I've got to keep my square root how it is, my pink function, keeping my square root, okay? And then all I'm doing is instead of x underneath my square root, I'm putting this in, okay? So I'm going to put x squared plus 1, right? And then I'm finishing off the minus 1, okay? So all that changed is instead of x right here, right, the minus 1 are the same, square root's the same. The only thing that's different is instead of x, you put in x squared plus 1, okay? And then we want to simplify. So these are all under a square root. It's not like over here where I have my square root squared and then we cancel each other out. What I do have is a plus 1 minus 1, and like we saw over here, 1 minus 1 is 0. So we're left with the square root of x squared. Well, you know squaring and square root are opposites that cancel out, leaving you just x. So yes, your answer would be yes, their inverses because it equals x. Okay, if they were not inverses, we would say no because they don't equal x, right? Okay, example 2. Given f of x equals 3x squared plus 5, what is f of the inverse of f of x? Okay, well, what we know is, see how when we plugged in f of g of x, right? Everything canceled out but x because they're inverses, right? Which means this is like saying f of its inverse of x. And everything ended up canceling except for the x, right? That's what it was equal to. So down here, it doesn't matter what this is because we know f and its inverse function, whatever its inverse function is, we know that they are going to cancel each other out, equaling x. Okay? I just want you to be aware of the difference. Here we are given two separate functions, one f and one g, and we wanted to determine whether they're actually inverses, right? So that's why I did this. Here, we're told f and its f inverse, right? So the inverse of the f function times f, and you know function and its inverse would cancel each other out, leaving us just x. All right, example 3, are these functions inverses? Okay, so it doesn't matter which one you start with. Let's just start with, let's do f g of x first. Okay, meaning we're gonna put the g of x function inside my f function. Okay, so equals, and instead of x, I'm putting square root of x minus 5 squared plus 5. Okay, and then I want to simplify. Okay, so since this whole thing is squared, right, I have to simplify that first, okay? This squared doesn't just go with the square root, so we can't just cancel that out. It goes with the whole thing. When you square something, that means you have that times itself, right? So that means I have this times itself. Okay, so we get square root of x times the square root of x, which would give me the square root of x squared. Then we get a negative 5 square root of x, another negative 5 square root of x, and negative 5 and negative 5 gives us a positive 25. If you don't know how I just did that, we've gone over multiplying, okay? But you would set up your box and you would say square root of x minus 5, square root of x minus 5. X times x is an x squared, so you get square root of x squared. And then we get negative 5 square root of x, negative 5 square root of x, and positive 25. Remember the diagonals usually like terms that you can combine. To me, it already looks like I'm doing way too much to see if these would simplify. Okay, so I'm guessing they're not going to be inverses, but let's see. So we get square root of x squared minus 5 square root of x minus 5 square root of x gives us a negative 10 square root of x plus 25, and then we have that plus 5. Okay, well, square root of x squared gives us x minus 10 square root of x. 25 plus 5 gives us 30. And nothing else we can do here, nothing else will cancel out, no other like terms that I can combine. I'm done here. Since it did not equal x, my answer is no. They're not inverses because not equal to x. Okay. didn't equal x, so the answer is no. They're not inverses because it's not equal to x, okay? If it equaled x, then they would be inverses, right? Not equals x, not inverses. And then we have example 4. These questions should be the easy ones that everyone gets right on the test. If you see f times its inverse, so you have one regular f and one inverse of f, okay? You should automatically know these cancel you out, leaving you just your x value. Well, here, our x value is equal to this. So your answer is whatever is inside of the parentheses. Okay? All that happened is these canceled out, and you're left with this, right? Like earlier when our example was f, the inverse of x, right? Everything canceled out, leaving us x. Well, here, it gave us a value for x. So when these canceled out, it left us our x value of 5.231. Okay? All right, so it gave me the function f, a cube root of x plus 2, and the inverse function equals x cubed minus 2. What is f times the inverse of negative 6? Well, you could sit there and plug the inverse function into f and simplify and then plug in 6 for your x. Or if you already know what we just talked about, function and its inverse cancel each other out, leaving you just your x value. So your answer is just negative 6, and that's all you had to do.